Hi, welcome to the mathcenter.com. We are continuing where we left off with the problem involving probability generating functions. Let's come back to this part here. Y is the sum of two independent observations of a random variable x. So we can write it as y equals to x1 plus x2. In part 2 of the problem, we asked to find the probability generating function of x, expressing your answer as a cubic polynomial in T. Okay, what's a cubic polynomial? It'll be ax cubed plus bx squared plus cx plus d. That's a cubic polynomial expression, yeah, ax cubed plus bx squared plus cx plus d. Now in this case, they're asking you to express your answer as a cubic polynomial in T. This is the general one that I've given you, so we will have something in T. In part 3, you asked to write down, so you're probably going to get very few marks. Yes, here it's given. You're only getting 1 mark for this. You asked to write down the value of probability of x equals to 2. So it's probably something that you can see from your answer because you have the probability generating function of x, so you can write this down straight away. Okay, a quick reminder, this is the probability generating function of y, so we'll keep an eye on that. Let's move it down. Yeah, we are told, before that, a reminder, we are told that y is the sum of two, what's the word here? Independent, yeah, observations of random variable y, random variable x. So y equal to x1 plus x2. So we can write the PGF, the probability generating function of y, as the product of two PGFs, yeah, and those PGFs will be representing the PGF of x. Okay, so we can write, okay, gy of t will be gx of t times gx of t. Remember, this is the sum of two independent observations of a random variable x. So using the independent property, we can write the PGF of y as equals to the product of the PGF of x and the PGF of x. Yeah. Okay, also keep in mind that the PGF, okay, the PGF of x is a cubic polynomial in T. Also keep in mind that this is the PGF of y. Note there are no constant terms here. Okay, there are no constant terms here, so we can write, let me bring back my solution. So we can write gxt times gxt as equals to at cubed plus bt squared plus ct times, let me get that, this is ct, yeah, times at cubed plus bt squared plus ct. Now that's what you see here. Okay, I've written gx of t, the PGF of x, as at cubed plus bt squared plus ct, and I need to multiply that by the same thing because, like we said, we are using the property of independence. And the reason that you don't have a constant term here, I just told you why it's not there, because looking at this, there's no constant term here, so we don't need a constant term. So this is gx of t and this is gx of t, and the product will give me what we have in the question, yeah, 0.09 t squared, 0.24 t cubed, all the way up to 0.09 t to the power of 6. Now what I did next was I looked at the coefficient of t to the power of 6. How do you get t to the power of 6? It'll be this term here multiplied by this term here. That's the only way to get t to the power of 6. So I'll have a times a is a squared. What do I have here? 0.09. So a squared is 0.09. I'll get a is 0.3. Done. Then I looked at the coefficient of t squared. How do you get the coefficient of t squared? By looking at ct and ct. So by multiplying ct and ct, you get c squared t squared. So the coefficient of t squared will be c squared. Again, when you multiply ct and ct, you get c squared t squared. And the coefficient of t squared will be c squared. And that will be equals to 0.09. So from this line, you can get c is also 0.3. And then I've looked at the coefficient of t cube. So t cube will be, I have bt squared times ct, yeah? Okay, and ct times bt squared. So I'll have the coefficient of t cube as 2bc, and that will be equals to what? 0.24. Clean it up, you'll get b equals to 0.4. So I have my PGF of x. Okay, I have my PGF of x, which is gx of t. Ct is c is 0.3, so 0.3 t. What is b? B is 0.4, so I'll get 0.4 t squared, and a is 0.3 t cubed, and we are done. Also, I like to remind you of the definition of the probability generating function. I've used s here. Don't get too alarmed by that. It's no big deal. You can replace it with the t. Gx, this is a formula, yeah? Gx of s is p naught plus p1s plus p2s squared plus p3s cubed, and so on. And p naught here is probability x equals to 0. P1 is probability x equals to 1. P2 is probability x equals to 2, and so on. So, I repeat, P naught is probability x equals to 0. P1 is, I repeat, I'm sorry about this, my dog is barking outside my room. Okay, let me say it again. This is the definition of the PGF, where P naught is probability x equals to 0, P1 is probability x equals to 1, P2 is probability x equals to 2, and so on. Yeah. So looking at my generating function PGF of x, I can write down the probability of x equals to 2 straight away. I'm just looking at this number here, the coefficient of t squared, which is 0.4, and we are done. Please like this video, please share with as many friends as possible, and please follow me on Facebook and YouTube. Thank you.